Hi, so this is going to be a tutorial on how to program the IRB2600 to act as a CNC tender. Okay, so we've got our environment here, and the first thing we're going to want to do is go to this button here and import an IRB2600. So I'll choose the 20 kilogram capacity just in case if you were manufacturing a heavy steel part, well, it would probably be more than 12 kilos if it was quite large. So just for that extra convenience, we'll select 20 kilos. There's only the 1.65 meter range model, so click OK, and then there's our robot there. Once we've done that, we'll import the environment around the robot. So I'll import, I've got a SOLIDWORKS assembly, so I'll import that in. So click and drag, and then that will take a bit, so I'll cut here and come back when it's done. Okay, so we've got our assembly in here. So the first thing we're going to want to do is move the entire assembly so it's the robot's in a better position. So I'll select that, and then what I'll do is I'll select the move tool, there we go, and then I'll move it along the X and Y axes. So I'll just check that the robot can reach all the conveyors. So what I'll do is I'll select the jog point tool. So that might be a bit far, so I'll just keep shifting the workspace assembly. Okay, that should be good. So I'll save here. So something else worth noting are the joint limits of the robot. So in this current orientation, the robot has a joint limit here at 180 degrees. And for this task, that isn't ideal. So we'll want to rotate the robot 135 degrees counterclockwise in order to negate this. So we'll right click on the robot, we'll click on position, rotate, and we'll rotate 135 degrees about Z, and we'll apply. Do you want to move the task frame? Yes, and yes to that as well. And then you can see the robot's rotated 135 degrees. So now we can move freely from picking up the part all the way around to putting it in the CNC and pressing the buttons without hitting the joint limit over here. So now that the robot's in the environment, I'll add an End Effector. So I'll click and drag the CAD model into the workspace, and then I'll hide the other components just to make it easier to see what I'm doing. And then we want to move the End Effector to the origin. So I'll right click on here, choose place, 1 point, select the surface select and center snap so that I can select the center of the bottom. So move from there to the origin, click apply. Okay, so that's in the right spot. Now we want to rotate it 180 degrees about X. So rotate 180, apply. So next we'll want to set a frame of reference to the tip of the End Effector. So I'll select frame, create frame, and then select the tip of the suction cup by clicking there. Click create, and there you can see we've got our frame of reference. So I'll close that and save. And now we'll create a tool from this model. So what we'll do is we're in the modeling tab and we click on create tool, and we'll call the tool SMC gripper. For the component we'll use existing, and that will be our End Effector model. And for the center of gravity we'll select part selection and snap gravity tools, and click in here and then click on the part, and that's our center of gravity. We'll click on next, and then for the target frame we'll use the frame that we just created, so frame 9, that name's okay, move it into TCPs and click done. And then there you can see we've got our SMC gripper tool there, which we can click and drag onto the robot, and then we want to update its position so it's on the end of the robot, so we click yes. And then if I make all the hidden components visible again, we should be able to see that the end effectors attached to the robot. Okay, so now that we have the tool for our robot, I'll actually create some targets for the robot to move to. So I'll click on target and create target and click OK. And then I'll set the position of the target using the surface select and center snap tools. So I'll click on the top of the part and click create. And then there you can see our target here. And I'll create a duplicate of that target and rename it to target 20. And then I'll offset the first target by 100 mil in the Z direction, just so we can have a path generated in between the 2 points. And then what we can also do is we can turn on view robot at target, and that will just let us see how the robot's going to be positioned at each target. And we can see that the robot's actually moving from underneath to the targets, and we want it to come from the top. So to fix that, we can change the orientation of the targets. So if we right click on target 10, and we click modify target, rotate, and if we rotate by 180 about X and apply, you can see that the robot's actually coming from the top now. So if we copy that orientation from target 10 and apply it to target 20, we can see everything works. And then now using these targets, we can create a path. So we select the targets, click on add to new path, which creates path 10. And we can see we've got our 2 move targets here. But before we generate the path, I'll just edit the instruction. So this lets me set the speed. So I'll set that to 600 for this application, and the zoning. So I'll set that to fine, and that just helps to avoid any path generation errors. I'll click apply. And then to generate the path, I'll right click on path 10, click on auto configuration and all move instructions. And then I'll zoom in just to get a better view, and right click on here and click on move along path, and you can see the robot moves along that little path we made. So I'll create a second path called main, and this path will act as the entry point for any other paths. So I can drag and drop them into here, and then when main is run, any paths inside will also be run. In the interest of time, I'll just copy and paste all the paths required to complete the entire operation, but the process is the same as adding these 2 targets here, just repeated for every point you want to move the robot to. So you can see that I've copied the tasks and path from my previous solution, and I can generate the path and then move the robot along the path. But you can see that the robot doesn't yet pick up the objects or move the door. It just moves along the path. So before we add the simulation logic, I'll just go into the Rapid tab and I'll synchronize the current program to Rapid. So yep, that's all good. I'll click OK. And now if we go into the main, you'll be able to see all of the targets are in here, and path 10 is in here, and in the main, path 10 is called. So that's the same as what we had in here. We've got our main, and inside the main we're calling path 10. Okay, so to make the robot actually pick up the parts and move the door, we're going to implement simulation logic. So what we want to do is we want to click on the simulation tab, and then we want to click on station logic, and then if we click on compose, we can add some components. So the first component we want to use is an attacher. So that will be used to attach the robot gripper to the work part to move it. So the parent in this case will be the gripper, and the child will be machining part 1. So if we apply that, there we go. And then the next component will be an attacher for the door. So therefore the parent in this case will also be the gripper, and the child will be the door. There we go. And we can apply that. Okay, and then we'll add another component, and this time we'll add a detacher. And this will be for the part 1. Apply, and that will allow the robot to detach from the machining part. So if we name this attacher to attacher part, you name this one to detacher part, and we rename this one to attacher door, and then we will add one more component, and that's a detacher for the door. There we go. So we'll add a positioner component, and that will be just so we can reset the position of the part to be machined. So we want this position to be the same as the position of the part on the conveyor here. So to find that position, I'll go to Layout, Machining Part 1, right click, Set Position, and then I'll take a snippet of this just so I can remember it, and then I'll close that, and then I'll go back to Station Logic, click on Properties. The part or the object to be moved is Machining Part 1, and I'll set this position to the position I took a screenshot of, so that was 7, -1399.27, and 755. And then the orientation should be 0. Okay, apply, close, and I'll rename this to positioner part. I'll also add another positioner, so that will be for the door, so we can reset the position of it. So object will be door, position will be, this is the home position we want to reset to, so I'll close this again, I'll click on this, we want to go door, right click, set position, and I'll take a snippet of that again, just to remember it. There we go. And if you go back to our station logic, right click, properties, set that to door, and then from the screenshot that I just took, that's the position 381.23, 2284, orientation is 90, 00, and apply that. And then I'll just rename this to positioner door, and there we go. So the next step is to go into the design tab, and you can see we've got all these actions, but we have no way to trigger the actions automatically in the code. So what we want to do is we want to add some signals for this controller. So if we go into the Rapid tab, we can go into Configuration and IO System, and then we can actually go into this Signal tab, and we can add in some signals here. So we'll right click on Signal, New Signal, and then our first signal will be called attach underscore door, and this will be a digital output, and the rest of the settings are fine as is, so click OK. So you can see instance error, we have to restart the controller for them to start effect, so we'll do that at the end when we've got all of the outputs. So we will copy and paste this one, copy signal, and then we'll just modify the name to detach door. There you go. And then if we can just keep doing this for all of the signals. So the next one is attach part. And then detach part. And then to be able to reset the door, we'll do reset underscore door underscore position, digital output. And then the last one will be reset part position. Click OK. And then now that that's saved, we'll restart the controller. And then just wait for this to turn green down here. And then those changes should have taken effect. Now that we've got our signals programmed in here, we can go back to the simulation tab, and within station logic we can go to the signals and connections tab, and under I/O signals we can add some GUI buttons to perform certain actions. So that will be our door and part position resets. So we'll click on add I/O signal. This is a digital input, and for the name, this is just the name that displays on the button, so we'll say reset underscore part, and that's fine. And then we'll add another one, so that will be reset underscore door. Okay. Next we'll move on to I/O connections. So these are signals that can be programmed to perform certain actions within the path. So this could be moving the door or moving the part with the robot. So first we'll click on add I/O connection, and the source of this signal will be the controller, and the signal we're going to send will be attach door, and we're going to send this to the attacher for the door, and we're going to execute that. So press OK. We'll repeat this for all of the source signals that we programmed just before. So add another I/O connection, we want the controller to send it, and then we'll do detach door. So that will be the detacher door object, and execute that, press OK. Same again, controller, attach part, and that will be attach a part, press OK. Controller, detach part, and then we select detach a part, press OK. Controller, reset door position, so this is to reset the door back to the home location. Position a door, OK. Add I/O connection, controller, reset part position, and this will be position a part, press OK. So we're actually resetting the door and the part here with GUI buttons, but we're also going to include this programmable action as well, so that when we get to the end of our code or the end of our path, we can call these and just reset the door and the part without having to even press these buttons, which can just be used as a backup. So next we want to go back to the paths and targets tab on the side here, and we actually want to add in some actions. So one of the actions we might want to add is for picking up the part so it actually moves. So what we'll do is, I'll just have a look in the tree. So we start at the home, move above the part, we move to part position 1. So after that, what we want to do is we want to be able to pick up the part. So what I'll do is I'll right click on here and I'll insert action instruction. So we'll leave that as is, we'll leave that as is, and here we'll select pulse do. So that will send a pulse of the signal that we specified in station logic, so it will send one of these signals, and we'll leave that as attach part, create. Okay, so then you can see we've added that there, but I'll drag that back up to where we want it, and I'll just copy that one, there we go, and I'll edit the instruction, and I'll add in a wait time. So what that will do, that will just let me pause the program for a specified amount of time. So for 1 second, I'll apply that. So I guess this is simulating like the gripper coming down on top of the part and then taking a second to pressurize the vacuum to pick the part. Okay, so I've got the camera in a good position to see the animation. So what I'll do is I'll right click on the path, auto generate it, right click, and move along the path. And then we should see it pick up the part. There we go, there's our pause and it picks it up. And then you'll see that it doesn't actually detach the part, So that's because we don't have any other actions in the path yet. So what I'll do is I'll go through and manually add all of those actions, but for the sake of saving time in this video, I'll just cut that out. Okay, so I've gone through and added all of the actions to this path. So now I'll just configure the path, and then we can move along it. So you can see the robot goes along, attaches to the part, then goes into the CNC and detaches from the part, then moves to the door and attaches to it, and then the door moves along with the robot, then the robot detaches from the door, presses the start button, waits for a specified amount of time, so 5 seconds in this case, presses the stop button, moves to the door and attaches to it, moves along with the door, detaches from the door, attaches to the part in the CNC, and then moves to the end conveyor, and detaches from the part, and then back to the home location. And then you can actually see that the part at the end there moved from here back to here, and that's just so we can have a loopable program. So you could continually have or simulate parts coming in this way and parts moving out along that way. So now that we've programmed all of our controller signals and inputs, we can go back to View, and then we can click on Simulation, IO Simulator, and here on the right we can actually see a list of all of our inputs and outputs for each of the controllers. So if we select the Station Signals controller, we can actually see our Reset Door and Reset Part buttons that were programmed in here. So as an example, if I move along this path, so we'll go along here to pick up the part. Now if I was to stop the program here, this part is now not in the correct spot to restart the simulation. So what we can do is we can click on Reset Part, so set that to 1, and then the part's reset. So no matter where this part is in space, we can press this Reset Part button and the part will move back to here. Okay, for our last step we need to synchronize our path with our Rapid program. So if we go into the Rapid tab and we click on Synchronize to Rapid and select all of these, click OK, that should synchronize our path with the main file under Module 1. So this code in here is the code that can be uploaded to a real robot. And just as the very final simulation, I'll hide the path just so you can get a better look at the robot.